Hello everyone, welcome to part 4 of the functions test review and study guide. We are talking about piecewise functions here. So I've got a functions that is broken up into 4 different pieces. I'm going to look at where the breaks are, where the discontinuity is, where I physically have to pick up my pen or pencil right there in order to draw the graph, right? There are 3 places where that happens, and that happens where x equals -3. It's known as a jump discontinuity, where there are 2 holes. And where x equals 2, there are a set of holes. And then where x equals 5, it's an infinite discontinuity because the function approaches positive infinity or negative infinity. All right. The range here, believe it or not, is all real numbers because every y value is defined. The only break in the domain happens where there isn't an output. That's where x equals -3, and that's where x equals +5, where those discontinuities are. Notice, though, at the discontinuity where x equals 2, the function is defined. There is an output right there at that closed dot. Okay, in 25, I'm also looking at a function that's broken up into 3 pieces and has a break here at x equals -2 and has a break here. Both jump discontinuities where x equals -2 and x equals +1. You might be able to remember that because in order to go from one piece of the function to the other, you'd have to jump. You could think of it that way. No infinite discontinuities because there are no asymptotes. The function is defined over all real numbers because, again, of those closed circles that give a definite output. The range is all y values except right here. I'll do that in red. Except for right here where there's an open circle. Oops, sorry. That's not true. That open circle is voided by the fact that this function is closed right there. The problem, the y value that we can't have right here is 6. There's an open circle, so I'm looking at a function that has y values that are less than, but not equal to, because of the open circle, 6. Okay. In the next one, I've got 3 pieces of this function, and if you look at this in 3 pieces, that'll be helpful to you. So if you just look at, pretend that these things aren't here for right now. Right? Just pretend that they aren't there. In fact, even pretend the domain restriction isn't there for now. If I just asked you to graph -3/2 x minus 6, that would be a line with a slope of -3/2 that would go through and have a y-intercept at -6. So what I'm asking you to do here really is, think of this as graphing the line, right, that would continue this way. But now I only want to see, now I can consider the domain restriction. Now I only want to see the x's that are less than or equal to -4. Well, that happens to be right out here. And so I am going to erase the part of the graph that I'm not interested in. Same thing for this next section. Right, let's look at the absolute value of negative, the absolute value of x. That's going to be the absolute value function that's been flipped upside down. But I'm only interested in the x values from -4 to 1. Right, so I'm restricting the domain from -4 to 1 on that absolute value function. We'll do that one in red. Okay, we'll do this one in blue. This should be an open circle. There we go. So that's the blue piece. If you have to do this in color, that's totally fine. This one is in blue. And then we'll do the last one in black. That's the square root function, which is going to look like this. Right? That's been moved how? Well, the new vertex is at 1, 3. So it's been moved up 1 to the right 3. Now I only want to see it for x is greater than 1. Well, that makes sense because open circle right there. Now I want to plot the graph to the right of 1. The domain here is all real numbers because I've got these closed circles in the middle where it looks like where there is a jump discontinuity at x equals -4 and x equals 1. The function continues, though, to the right and to the left, so the domain is all real numbers. And the range, I have to look at my lowest and my highest. Well, my lowest y value is down here at -4, so I want all values that are greater than or equal to, because of that closed circle, -4. And you can see that the function just continues to go up. Both the blue and the black lines continue to approach infinity, so that's why it's all y values greater than or equal to -4. End of the video on transformations and piecewise functions. Stay tuned for the next